Giving you a little bit of bell work. And this might seem silly, but we're making some really simple mistakes that we can rectify in a hurry. Okay? So what's the deal here? 1 times 1 times 1 times 1. What's the answer? 1. Does it matter how many ones we multiply together? No, it doesn't. Now, I think sometimes we forget that, though, when we get something like this. 1 to the 3rd power. Or 1 to the 10th power. I see on your tests, I don't know if you guys are still thinking this way, or you're just doing it quickly, or what, for whatever reason, but you're telling me that this is 3 and this one's 10. Is that possible? I mean, doesn't this literally mean 1 times 1 times 1? And this means 1 times 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 1, which is still what?
1.
1. Jim, you paying attention? Say no, but I am now. Okay. Now, how about negative 1 times negative 1? How about negative 1 times negative 1 times negative 1? Okay, now we have to start thinking a little bit anyway, don't we? We have to start counting up the negatives and doing the odd even thing, don't we? So 4 negative 1s multiplied together? Positive 1. Okay, so then negative 1 squared, what is that going to give us? Positive 1. 2 negatives, right? 2 negatives multiplied together. How about negative 1 to the 3rd power? Negative. Because there's 3 negatives, right? It literally tells you right there. Okay? How about negative 1 to the 4th power? Now we're back to positive, aren't we? So if I have negative 1 to the 17th power, what are we talking about? You guys actually thought way too long about that. Okay? Let's try that again. Are you all ready this time? Ryan, you looking? Negative 1 to the 17th power is? Oh, now we're catching on. Okay. How about negative 1 to the 100th power? Okay. So, is that cleared up a little bit for us? Okay. Now, when you have a problem like A times B times C, and maybe A is a 2 and B is a negative 3. Ooh, let's do C cubed. And C is a negative 1. What's going to happen if you don't use parentheses when you do your substitution? It's not going to work, is it? Okay. You know, you can't just put a 2 here and a negative 3 for B and a negative 1 for C. Is that going to work? Does this problem say 2 subtract 3 subtract 1 cubed? In fact, is there any subtraction in our problem? No. But if we replace with parentheses, like that, right? Okay. And what is negative 1 cubed? What? How come only 2 of you answered me, or 3? Come on, Nikai. What's negative 1 cubed? Negative 1. We don't need that cube there, do we? So now when we multiply, how many negatives do we have? 2. So what's the answer going to be? What's the answer going to be? Positive. Okay. I wasn't even worried about the 6 part. I'm just worried about the sign of the answer right now. Okay. And even if it's, gosh, this and this, those are not the same thing, are they? Gage, you're not looking.
Sorry.
What does this mean? Negative 1 times negative 1, which is positive 1. What does this mean? 1 squared. Now what's the opposite? Very different, right? Okay. And this is the stuff we are kind of struggling with on the test, I noticed. I mean, not everybody or anything, but it's something we really need to pay attention to. The other stuff, okay, you guys got your paper where you did your bell work before, right? I want you to do this. I'm getting some funny answers on the test, I noticed, and on your homework. What is 2 times 2 times 2? 8. So 2 times 2 is? 4 times 2 is? Okay. What about 2 times 2 times 2 times 2? So you didn't have to go back and do the whole thing again, did you? We already know that answer, don't we? It's 8 times 2 is? What? 16. Okay. What about 2 times 2 times 2 times 2 times 2?
You still want to write it down?
Eh?
You still don't want to write it down?
Yeah.
All right.
What is it?
32.
Okay. So I guess we should have put 2 times 2 up here in the first place, right? Which of course is 4. So 2 squared. What's that? 4. 2 cubed.
8.
A couple of you are answering me. 8. Okay. Okay. 2 to the 4th power then. 16. 2 to the 5th power. 32. What's 2 to the 6th power going to be?
64.
64. Okay. I think we're struggling with that a little bit. But now, let's go the other way. Let's go the other direction. The square root of 4.
2.
Okay. Now we're too lazy to write 2 right here, but you can write a 2 right there and say the square root. How about the cube root then of 8? 2. You see why? Y'all see why? Okay. How about the 4th root of 16? 2. What am I going to ask you next? Can you tell already?
32.
Yeah, the 5th root of 32, which is 2. The 6th root of 60. What number times itself 6 times is 64? 2. I think we talked about this. We said the answers, but I don't think you guys have actually done it. And so sometimes you give some crazy answers, especially on these. That one right there.
That's 9.
Yeah, we struggled with that one. What does this say? What number times itself 3 times is 27? And I get 9. I get 9 all the time. But I'm telling you, 9 times 9 times 9, it ain't 27. Is it? It's a heck of a lot bigger than 27, isn't it? I mean, 9 times 9 is 81, and then 81 times 9, not 27, is it? No, it's got to be a lot smaller than 9.
3.
Oh, now we're talking. 3 times 3 times 3. 3 times 3 is?
9.
Times 3 more is? Ah, now we're getting somewhere. Now we're getting somewhere. Okay, so 3 to the 3rd power then is what? 27. The cube root of 27 is 3. Remember on the assignments, you were given problems like this. 3 cubed plus the cube root of 27. Why is it giving you that problem? Aren't they just exact opposite questions? 3 times 3 times 3?
27.
Plus, what number times itself 3 times is 27? Well, we just did that. Right? Is that what you thought to yourself when you did the problem on the assignment? If you did not think that, then now I know why we missed that on the test, huh? Okay? Now, the thing with cube roots is sometimes we have to worry about negative numbers. We don't worry about negative numbers with square roots. I'm never going to ask you this question.
Let's equals -2.
What number times itself is negative 16? Well, can you guys think of a number that times itself is negative 16? See, 4 times 4 is 16, and negative 4 times negative 4 is 16. They're both either way. See, if we have 4 squared, we get 16. If we have negative 4 squared, don't we still get 16? Okay, so this number, sometimes we say it's not a real number. It's not on the number line. It's not on our normal number line that you think of, okay? And so that's the real numbers. Every real number is on the number line. So we say this is not a real number. But that's kind of a bad thing to say because it makes it sound like it doesn't exist or something like that. It's just not on the number line. Okay, it does exist. That is the answer. There is an answer. It's just not on the number line. And it's not something that we have to worry about this year. It's something we'll worry about later. Now we will do cube roots though of negative numbers. Like the cube root of -8. Okay? First thing, it's negative, guys. The cube root of -8 has got to be a negative number. Don't you think, Thomas? Gotta be. Okay? So, and then what number times itself 3 times is 8?
2.
There you go. Okay? How about the cube root of -27? It's negative. Negative what?
3.
Yeah, -3. We could do this one too. The cube root of -1. It's negative. Isn't it? Doesn't it have to be a negative number? So, negative what?
1.
1. How about the cube root of, I don't know, 64, -64? It's negative. Right? Yeah, it's got to be negative. Negative what?
4.
It is 4. Everybody do it. 4 times 4, 16. 4 times 4, that's 16. Times 4 more, 16 times 4, 64. There you go.
There was a problem on my test yesterday that I didn't send.
There was a test problem like this?
Yeah, exactly.
Oh my gosh! I can't believe it.
Because when you do this, it makes me kind of seem like I did really bad on my test.
No, I got to tell you guys, I got a hand cramp writing very good on your tests. You did a great job on your test. But I just thought it was funny that we were missing some of the easier ones, you know. So, okay, now there's one more cube root that you guys have to keep track of, and that would be this one. The cube root of 125, 5. The cube root of -125 is negative, right? Now, anything higher than that, any cube root with a larger number than that, we're going to use a calculator. But we should know 1 cubed, 2 cubed, 3 cubed, 4 cubed, and 5 cubed. Those are small enough that we can deal with them. Okay? All right, so.
Let the suspense build up on the test.
Am I letting the suspense build up on the test? That's because not everyone has taken it yet, so I can't give it back. But I will give it back at the end of the period. And you did well. Very, very good. Okay. So today we're going to start solving equations again. So we looked at equations that were just kind of one step. And I just showed your work and everything, right? So what do we have to do to both sides, everybody? Okay. Subtract 4, and you're showing me the subtraction symbol, right? Okay? And you're putting a big add subtract line underneath. And what do these add up to?
0.
And we don't have to worry about them anymore. And so we have 1x equals 16. And does that make it true? Does 16 plus 4 equal 20?
Yes.
That works. Okay. This one, 1/2 equals y subtract 2/3. So what do I need to do to both sides in order to solve this equation so I can see the answer?
That's 2/3.
Okay. So if I add 2/3 on both sides of the equal sign, it's not so simple here. These do add up to 0, right? Hey, this is important. These add up to 0. They're gone, right? So y equals, and we just have to add 1/2 and 2/3. What's our common denominator? You're always thinking that. So here I got to multiply by 3 over 3. Is 3/6 the same as 1/2? Is it the same number? Okay. Here I'm going to multiply by 2 over 2. So 4/6 and 2/3 are the same number, aren't they? And now we can add. So we add these together, 7 over 6. And you don't have to change that to a mixed number or anything. 7 over 6 is fine. So 1/2 equals 7/6 subtract 2/3. That's the number that makes it true. Okay? Now, today we're going to look at different type of equations. Notice, you guys notice on every one we've done so far, what has been the coefficient of the variable? It's been 1 every time, hasn't it? We haven't even worried about it. We haven't even been writing it down. Okay? But it's not always 1. In fact, it's rarely 1. Most of the time it looks something like this. See, the coefficient of our variable is not a 1, is it? But we need it to be a 1. We need this equation to say 1y equals some number, and that number is going to be the root. It's going to be the number that makes it true. Now you all can look at this and tell me the answer, can't you? What's the answer?
7.
Yeah, it's 7. 7 is the number we plug in for y would make it true. I'm not worried about that today. Today I'm worried about show me the work correctly. Okay? What do I need to do to both sides of this equation in order to find the root?
Divide by 3.
Okay, now watch how I show my work. I don't do a big add subtract line or anything. I do a fraction line. You guys think of this as a fraction line. I think of it as a divide line. So whenever I see this, I think of it as a divide line. And don't, oh goodness gracious, don't do this. Don't do the slanty fraction lines.
Oh, no, those are the worst.
Those are the worst. Okay, don't do those. Horizontal like this. Notice it's not one big solid line, isn't it? I'm dividing each side individually by 3. Now, remember before when we crossed out the thing, it was gone. Like if it said 3 plus y equals 21, if I subtract 3 from both sides, what happens to these? They add up to 0. They're gone. Right? Gone. Y equals whatever. Okay, we don't have to worry about that. Over here, though, it's not gone. Yeah, it's a 1. 3 divided by 3 is 1. And for a while, we are going to write 1 times y equals 7. You're going to write the 1 until I'm convinced it's in your brain that it's there. Can we do that? Okay, it's not a big deal. Now that one you could just see the answer. A lot of them you can just see the answer. I don't know, 45 equals 9 times a. I don't want not, yeah, boom, 5. I don't want 9 times a, I want 1 times a. So what can I do to both sides? Yeah, I can divide by 9. And what happens here? Is that gone? Yeah, it's a 1. So I still cross it out like this, but it's not gone. It's a 1. That's a big, big difference, guys. So 5 equals 1 times a. That's what your work's going to look like. Okay? Now, here's one that Matt's not just going to yell the answer out. Ready?
I'll try.
Okay.
No.
Okay. We cannot see the answer just like that, can't we? Even though it's a very simple equation, it's one step, seeing what the answer is isn't just as simple as that. But I want you to think about this. What's the opposite of timesing by 5/7? Dividing. Okay. Now, how do we divide by 5/7? Yeah, we times by its reciprocal. Now, remember that thing we did? We talked about reciprocal, and then we did all those questions about what happens when you multiply a number by its reciprocal. You get +1. You get +1. Isn't that what we want the coefficient right here in front of x to be? We want the coefficient of x, we want it to be +1. So if we times it by its reciprocal, what's going to happen? I'm going to get +1. Every time that'll work, won't it? So 1x, and then here's the thing though. If we multiply one side of the equal sign by 7/5, but not the other, is it equal anymore? No. So we do the exact same thing over here. And let me show you a mistake people make. Sometimes I get kids that will times this side by 7/5, and they'll times this side by 3/2. But would that keep it equal? Are we doing the same thing to both sides? No, we've got to do the same thing. So over here we're going to times by 7/5. So we're doing the same thing on both sides of the equal sign. And we want to reduce if possible, but I don't see anything we can reduce. So 2 times 7 and 3 times 5. It was so obvious, wasn't it? Okay. Now, what if the coefficient is negative? Negative 4y equals 36, or even negative 36. Right. Yeah, you divide by the net. See, what do we want the coefficient of y to be? +1. Right, everybody?
Yeah.
+1. So if I divide both sides of this equation by 4, that's not going to do it. Is it? Okay, that is not going to do it. If I do this, what I'm going to get is negative 1y equals negative 9. That's not what I want to know. Now, it's true. I didn't break a rule. I divided both sides by 4. Okay, that's not rule breaking. Okay, but it didn't solve our problem, did it? We want this to be a positive. So if we divide both sides by negative 4, what's negative divided by negative? And what's negative divided by negative? Which makes sense. If the opposite of y equals negative 9, doesn't y equal positive? So there you go. Positive 1y equals 9. Okay, you got your paper there, right? So I want you to write this equation down. Simple equation. And I want you to solve this and show me the work. Don't work from right to left, work top down, right? Work from the top and bring the equation down step by step.
I just like the software chair.
Do you think I teach you? You haven't paid attention to a single thing I've said. Turn around talking to people. You're looking at the task. You're doing everything you can do except pay attention to what I'm telling you. If you don't change that, it's not going to happen. You got to get it done.
Super simple, right? All we had to do is say, well, I'm going to divide this side by 4. I'm going to divide this side by 4. What happens here?
1a. Positive 1a.
There you go.
Equals positive 25.
Does your work look like that?
Yeah.
Okay. It's got to look like that. How about this one? Okay, what did you do to both sides?
Divided it by 2.
Now, do you have a fraction line on each side? Not one big one. And you have the 6 here and the 6 here.
Yeah.
And these cancel, and you get negative 5 equals 1x, correct? That's all it's got to look like. Okay? Here's another one. Now remember, think of the 7 as a fraction. Whenever you have fractions in your equation, think of them all as fractions. So even this whole number, we're going to think of it as 7 over 1. Are you guys using a dot for times or an X for times? Don't do that. What are we going to use to show multiplication here? Yeah, parentheses. So we don't want to use a dot or an X or anything right now. So if I multiply both sides by the reciprocal, will it still be equal? It'll still be equal. And what happens when we multiply a number by its reciprocal? You get positive 1. So 1 times a, that's what we want, isn't it? And this doesn't reduce, so it's just 35 over 2, which is a perfectly fine answer. We don't need to change that to 17.5 or anything like that, just 35 over 2. Okay? Let's see what you can do with this one. What do you think? What's happening to the variable here? Is it being multiplied by 3? It's being, okay, what's the opposite of dividing by 3? There you go. Do the opposite. So on both sides of the equation, we're going to multiply by 3. What's going to happen to this 3 and this 3? No, they're not 9. Hold on. This 3 is up in the numerator. This 3 is in the denominator. What's going to happen to them?
Oh, cancel out.
Yeah, they're going to cancel out and give us 1 times x, which is what we want. So 1x equals... Now, is that the number that makes it true? Does 21 divided by 3 equal 7? Yeah, that's the root.
Wait. Did you just times like 7 times 3 then? One side?
Well, I multiplied both sides of the equation by 3.
Yeah.
So I just went 7 times 3 is 21 here.
Oh.
Okay? Now, mixed numbers. Don't write down 2 1/4. When you write down the equation, so you can solve it, what are you going to write down?
9 over 4.
9 over 4. There you go. 9/4 x equals, and don't even write 3. Write 3 over, what? 3 over what?
1.
Yeah, think of it as a fraction. If you think of them all as fractions, it'll make your life easier. Do it. Hey Jim, what's the opposite of timesing by 9 over 4? Timesing by its reciprocal, dividing? Okay. Lilith, what happens when you multiply a number by its reciprocal? Yeah, you get positive 1. Now, over here, we could say 12 over 9.
Which I did.
Which we did, which I'm sure some of us did, okay. And we could reduce 12 over 9. Doesn't 3 go into 12 4 times and 3 goes into 9 3 times? So you can do it like this. Or what about up here? Can we reduce before we multiply? Sure. 3 goes into itself once and into 9 3 times, so 1 times 4 over 1 times 3. It really doesn't matter when you reduce, but you need to do it at some point. Okay? There are 4 problems at the bottom of page 104, practice problems, A, B, C, D. Can you all find them? I just want you to do A and B for right now. So everybody do A and B, and we'll talk about those. Okay? Looks like you're not quite. That's better, Thomas. Oh. Okay, here we go. So, first one. Did you put the 27 over 1? Probably not a bad idea. So I'm just going to, this is my brain. Okay, this is 3/5 times x, so I'm going to do the opposite. I'm going to divide both sides of the equation by 3/5. And yeah, so that means times by the reciprocal. I don't put a fraction line underneath. This would get super complicated. 3/5 x equals 27. Okay, I'm going to divide both sides by 3/5. That's correct. There's nothing wrong with that, really. But how do you divide by 3/5? Yeah, you got to times by its reciprocal. So eventually we got to come up here with 5 over 3 in order to actually do the division, don't we? So let's just get to it. Let's just do it. So this gives us 1x. Did you all write 1x? Got the 1 there? And then we could go 27 times 5 over 3, but I'm going to reduce first because my brain works better that way. So I'm going to say 3 goes into itself once and into 27 9 times. And 9 times 5 is 45. So 3/5 of x is 27. That's kind of hard to check to see if that's right or not. But we can sort of check it. Think of it this way. This says a little more than half. You with me? Look at this. 3/5. Is that a little more than half? 3 out of 5? You with me? A little more than half of 45 is 27. Does that seem reasonable? Okay. If it seems reasonable, 99% of the time you're correct. If you do one of these incorrectly, your answer just won't be reasonable. There's just no possible way. It'll be this number, might say a little more than half of, I don't know, 500, or a little more than half of 8. A little more than half of 8 is 27. Is that going to work? No, you can tell that that's not possible. Now over here, I hope that you remembered what I said and just wrote down 16/5. And I'm going to write 32 over 1. Mixed numbers are extremely difficult to multiply and divide, so let's just not mess with them. Okay? So we can come over here, we can multiply by the reciprocal. This is going to cancel and give me 1 times y, which is what I want. And have you noticed that these are kind of made up problems? They're nice, aren't they? They always reduce nicely. 16 goes into itself once and into 32 twice. So 2 times 5, that's 10, isn't it? So let's see if that makes some sense. 3 1/5 times 10 is 32. A little more than 3 times 10 is 32. What do you think? Is that reasonable? A little more than 3 times 10 is 32. That's a reasonable result, isn't it? Okay? There you go. Now on C, I would just want you to watch me. X divided by 1/4 is equal to 20. And I'm going to write 20 as 20 over 1. Now think. Look at me. Think. X divided by 1/4. The opposite of dividing by 1/4 is multiplying by 1/4. I'm going to multiply both sides of this equation by 1/4. I'm not doing the reciprocal. I'm not going to do the reciprocal because it says divide by 1/4, and I want to do the opposite of divide. What's the opposite of divide? It's times. If I want to divide, I times by the reciprocal. If I want to times, I just times. Now, this 1/4 is in the numerator. This 1/4 is in the denominator. It's kind of like this. What's going to happen to these 1/4? They cancel and give us 1 times x. And 20 over 1 times 1/4, isn't that just 5 times 1? 5? Let's see. 5 divided by 1/4 equals 20. If you take 5 things and divide them by 1/4, can we get 20? What happens if we take one thing and divide it by 1/4? What are we going to get? 4. What if we took 2 things and divided them into 1/4? What would we get? 8. See what I'm talking about? Okay. Plus you can see too, if we times both sides by 1/4, well, if we divide by 1/4, I don't want to get in. I don't want to do that. That's going to confuse you. There. Answer is reasonable. Let's do the next one. Just watch. X divided by 2 1/4 equals 5. Okay. I hate mixed numbers. That's 9/4. And I'm going to think of 5 as 5 over 1. That easy? Okay. Nikai, what's the opposite of dividing by 9/4? Timesing by 1/4. Yeah. Okay. So I times by 9/4, not the reciprocal, because I literally want to times by it. What happens here and here? Yeah, good, they cancel out. And I end up with 1 times x equals, now this is kind of ugly, 45/4. But that's the answer. That's the number that makes it true. Okay, did you learn something today? Okay,
Yeah.
let's do set number 24. Get after it.